Hello, Professor. Yeah. Okay. Yeah, that would be safe for 36. Oh, that's my whole thing. He's like, sorry. No worries. Like, no worries. We had for a couple. I lost it. I saw that.
Any news about it? Not yet. Probably next week. Thanks. Easy.
Yes. Yeah, it's doesn't sound so good. It's like you call it. What's wrong with Saturday? Yeah, I don't have 45. 2 hours of sleep. I was like, what's going on? I like screaming at the phone and get it's all shit. Yeah. But you spend a hundred garage shaking out. And all of a sudden, I'm like, why not? And I was better, so rising. It's like, so nothing I can see without. No. You know, the big one. You know, big wood. Oh, five. Yeah, not exactly. So this is like parts of stuff.
All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Good to hear. All right, so welcome to day 2 of EGME 401. So today we're going to start in earnest, and so we have full set of notes today. Okay, so a couple announcements before we begin. I know I was a little bit late posting the recording from Tuesday, but that is on the Canvas site now. So you should see the Canvas site has been updated. I kind of switched some things around just because we we had a full week of lectures this week. And I posted the recording for Tuesday. So definitely check it out if you want. This lecture's recording should be up before end of the day today. Right? For those of you on the wait list, I think I talked to the department about it, but we're not going to make any moves until next week, just because during this first week, a lot of people kind of move around naturally. So so just stick tight until next week if you're on the wait list, and I'll have an answer for you by then. Okay. All right. Are there any questions I can answer before we get started for today? Okay. Everyone on Zoom hear me okay? Probably should check this on Tuesday, but I think it was okay. All right, I'm gonna assume you guys can hear me because my mic, I can see it going. Okay, good. All right, so let's go ahead and get started. So today's gonna be our first real lecture. Okay. By the way, so this is kind of the mode that I'll be lecturing through, for most of the semester. So I have my iPad here connected through the Zoom. Everyone in class can kind of see the projection from the console here, and then of course everyone on Zoom can see my screen share as well. Okay, so today we're just kind of introducing some kind of very basic topics. So today we're going to be talking about interest rates or interest, equivalence, and a concept called the time value of money that we're probably going to end with today. Okay. All right, so let me first, let's start by just, like we talked about on Tuesday, this class is going to be quite a bit different than a lot of your other engineering courses. So we're still going to be doing calculations. So we're still going to be doing math, but we're not going to be doing any kind of, physics or, the math that we're doing is going to be purely kind of economical. Okay. So EG 401. What we said on Tuesday was that EGME 401 focuses on a lot of the non-technical skills, a lot of the non-technical knowledge that you need to succeed as an engineer. Of course, a big part of this class is going to be engineering economics, and so we'll be talking about money. I think probably infinitely more than all of your other classes, except maybe senior design. But we'll also be talking about ethics. And I'm also in conversations with the professor from the business school, and then I'm going to see if he can come by and do a couple workshops as well to kind of help with entrepreneurship and just general presentation business skills. Okay. And so another way to kind of summarize this, or another way to put this, is that EGME 401, we're going to focus mostly on decision making and resource management that goes into kind of these larger engineering projects. Okay. And as engineers, you're going to be expected to have knowledge of these things in order to succeed, right? Even if you're not going to be, even if management is not your ultimate goal, even as an engineer that's working on the design or analysis, you need to be kind of at least cognizant of a lot of these, a lot of these concepts, a lot of these ideas, because you're going to be working within these kinds of constraints that the company imposes on you. Okay. So no matter what your role in the company is, I think sometimes a lot of people get into the mindset of, we have our engineers and we have our business people. And a lot of what we're going to learn in this class is kind of what a lot of people would classify as that's the business people's realm, right? You still need to kind of understand it so that you can kind of participate in this, and then make sure that you have the resources you need in order to complete the project in the best way possible. Okay. Okay, so let's start with just some very basic concepts. So let's start with some very basic definitions. Okay. So first one is cost. Pretty self-explanatory. Cost is something that we're familiar with on a daily basis. But the way that we can define it here is that basically any money that you pay out that represents a loss in money, either for yourself or for your company or for the project, that's what we define as a cost. Okay. Right, so cost comes in many forms for an engineering project. We'll be talking a lot about this throughout the class. But some examples of costs that we'll see very often are things like initial costs, or a cost that's needed to start a project. Initial cost could be, paying for the equipment that you need to run your project, or paying for the materials that you need. Usually a lot of engineering projects are, you have a very large upfront cost just to get started, right? And so we classify all of those as the initial costs. Okay. Other costs that you may have is performing routine maintenance. So we call those maintenance costs. Okay. That's also a very common thing as well. So usually a lot of very large engineering machines require regular maintenance that you need to pay out. Okay. And a lot of times these maintenance costs increase over time as well. So as your machines get older, they usually require more maintenance, more material, more oil to kind of keep them running well. As is the case with most pieces of machinery, right? Just like your car. Right? And sometimes, we can even think of costs in terms of making an investment. So usually when you make an investment, you pay a large amount of money up front with the promise or with the hope that, it's going to pay off much larger down the line as well. Okay. And so these are just some examples of costs that we're going to see throughout the class. All right, number two. So the second definition that we'll start with today is called benefit. Okay. Benefit being the opposite of a cost, right? So usually when you think of making money, you probably think of terms like revenue. You probably think of things like earning money. But we use the term benefit just because revenue or sales or anything comes in lots of different forms for engineering projects. So we just use the general term benefit. Okay? So the definition for benefit is any money that comes in to you, which represents a gain or a positive influx of money. And so the most common examples of a benefit in an engineering project could be through the sale of a product. And that product could be something physical, something that you buy in retail, or it could be a service of some kind. I think it's becoming more and more common nowadays. Or kind of going back to our definition for cost, a benefit can be kind of cashing in on an investment of some kind. We're also going to use the term benefit to represent maybe some non-monetary or non-economic, positives to an engineering project. Right? So these are probably most common in public works projects, right? So any kind of construction work you see on the roads or the freeways, those aren't a sale per se. Like, you're not selling the freeway to people. In some ways, we partially pay for it through our taxes, but that usually isn't represented as a financial benefit to that specific project. Right? Some examples could be public works projects. These kind of benefit the population or people just in general. Maybe some projects that benefit the environment specifically. Or research. That's probably a very common one as well. Okay. And so if you end up, graduating from here and working in R&D, your work doesn't directly translate into the sale of a product. But the hope and the idea is that you're researching better technology, better methods. That's going to ultimately lead to something good for the company. But in the short term, R&D doesn't produce anything per se. All right. And so in general, for most engineering projects that take place in a commercial setting, it's desirable to have greater benefits than the costs.
Hey, Professor, can you hear me?
Yep. What's up?
I was going to just ask about R&D. If you're stating that sort of as a non-financial benefit,
Mhm.
where does the money come from in pursuing that field?
Yeah, no, that's a good question. It depends. It really depends on the context. So if you're talking about like a public works project, like some kind of something that the city or the county or the state may be funding, right? Usually a lot of the constructions you see on the roads are funded by the city itself. So that's usually where it comes from. And that money, of course, comes from taxes, property taxes, sales taxes, things like that. If you're talking about like research and development, that's usually funded by the companies themselves. Usually in any kind of excess benefits that you get from their sales, they pour that into research and development. And a lot of companies see that as kind of like an investment into a future product that's going to produce something, commercially viable from there as well. So it depends, but yeah. And the way a lot of engineering projects are designed, because they're kind of a longer term, they have longer time horizons, having higher benefits than cost doesn't necessarily mean it has to happen right in the moment. But maybe over the course of, 3 years, 5 years, whatever the project horizon may be, you want those benefits to kind of overtake the cost over that time. But usually in the short term, a lot of times in the short term, with like material costs and upfront costs, you're not going to see, the benefits outpace the costs, at least not for a long time.
Cool. Thank you.
Mhm. Okay. And so a lot of the economic analysis that we're going to be doing is kind of working under this goal that ultimately we want to have higher benefits than costs. All right. Any other questions any questions on this so far? Okay. All right. So let's talk about kind of a tool that we're going to use quite a lot, just because when you're talking about money, you're oftentimes you're throwing a lot of numbers around, and it can be hard to kind of keep track of everything. Next thing we're gonna go over is something called the cash flow diagram, which is a nice way to kind of visualize a lot of these things, especially for a longer project. Cash flow diagram. Basically, cash flow diagram is a visual way to show the costs and benefits throughout the life cycle of an engineering project. All right, and the way it looks like it basically just looks like a timeline, except we add arrows to represent different costs and different benefits occurring at different times. Okay, because not only is it important, when you have a long-term project like this, to keep track of all the costs and benefits, but it's even more important to kind of keep track of when these are recurring, because based on interest rates and things like that, that's going to be a very important piece of information. Okay. Okay. So I think the easiest way is just to kind of show you using the example. Okay. All right. So cash flow diagram looks just like a number line, and so we start here on the left, right? And we use little tick marks here to show different points in time. Cash flow diagrams always start at time 0. Okay? This is really important, right? So time 0 represents now, right? So cash flow diagrams are always going to represent the amount of cash flow that are coming in the future. Okay? So we're going to always start at 0. This represents present time. Oops. Okay. And then from there, we just count upwards. So the next tick mark's gonna be 1, next one's gonna be 2, 3, 4, 5. Okay. So this one just has 5. I just, it doesn't always have to have 5. I just, drew 5 tick marks. Okay. All right. And so what these numbers represent, they can represent months, they can represent years. It really depends on your project. Okay. But the important thing is to kind of keep each tick mark kind of separate. Right. All right. And so how do we represent things? So I'm going to use colors right now just to kind of illustrate this, but you can easily do this without the colors as well. Okay. So any cost that your project is incurring is going to occur with the down arrow below the line, right? So let's say for this particular project, we have an initial cost of $1,000. And so we can represent that as a down arrow occurring on time 0, right? Again, you don't have to use red, but I just used it just because, okay? And then let's say with this project as well, you can tell it's been a while since I've drawn these, because normally I draw the numbers offset from the tick mark, so I don't, draw over them, but, it's been a long Christmas. So let's say with this project as well, we have a recurring cost of $100 per month. Okay. And so we can represent that using smaller arrows, on each of the future months. Okay. All right, so all the costs we're going to represent with down arrows below the line. Okay. Any benefits are going to be represented with an up arrow above the line. Okay? So let's say that this project here is expected to draw in $300 in sales each month or each period. Okay? And so we can represent that using an up arrow on each period here. Okay, where each up arrow represents $300. And then sometimes what can happen, and this usually occurs at the end of a cash flow diagram, right? Usually the end of the cash flow diagram represents the end of the project or end of the project life cycle, right? And so at the end of the project life cycle, we have something called a salvage cost or a salvage benefit, let's say. Okay. which is an additional benefit that you get at the end. So usually, you know, once an engineering company is done using the materials, anything left over or any machinery that they're not going to use anymore, or maybe they'll disassemble it for the parts. They often try to sell these to other companies, so you get kind of a little bit of a boost at the end. So let's say we have another $400 in salvage costs, or excuse me, salvage benefits at the end. All right, and so to summarize, you know, this cash flow diagram, you know, if I were to explain this in words, okay, this cash flow diagram represents a project with a 5-month time horizon. Okay, meaning that the project is expected to last 5 months. Okay. All the cash flows for this project are all visually indicated in the chart, but we can describe them with words as well. Okay. And so the first thing that we had was a $1,000 initial cost. Occurring at time 0. So we see that as the big $1,000 down arrow that we're putting at time spot 0. Okay. We also have a $100 recurring cost. Okay. That represents the maintenance on whatever engineering machine that we're you know, that we're maintaining. Okay. So those are represented by smaller down arrows on each of the time periods there. Okay. We have a $300 recurring benefit. Representing the sales of the product or service. And the last thing we have is a $400 salvaging benefit. At the end of the project. All right. So that's how I would describe this project using words and also using the visual cash flow diagram. Okay. All right, so this is important, and so it's good practice to kind of, you know, take these words here and kind of see how they're represented visually, because a lot of the problems that we're going to be doing in the first half of the class are essentially going to be word problems, right? So I'm going to describe to you a situation using words, and it's going to be up to you to kind of pull these numbers, classify the costs and benefits, and ultimately put them into a cash flow diagram so that you can represent it and do kind of further analysis, further calculations. Okay. But usually in these types of economic problems, drawing the cash flow diagram is the first step to solving them. Okay. All right. Any questions on this so far? Okay. All right. So one thing to note about cash flow diagrams, you may have picked up on this, is that all of the cash flows, so all the costs and benefits, you've noticed that I put them at the tick marks exactly. So at 1, 2, 3, 4, 5, right? You may be wondering, you know, is it possible to have a cash flow that occurs maybe in the middle of the month, right? Something like this. Right? Technically, that's possible, right? And so if you think about the sale of a product, you know, the sales of a product or service usually occur all throughout the month. But just for simplicity, what we usually assume is that every cash flow that occurs during a certain period, we kind of lump it all together at the end of that period. Okay? Note. Okay. Again, that's just for simplicity's sake. Right? You'll see once we start doing calculations with you know, with equations and things, it helps us tremendously to have this. Okay. Okay, so let's do another example. This one a little bit more probably a little bit more easy to visualize. Okay. So in that last example, we started with the cash flow diagram, and then I kind of described to you kind of what each of the different cash flows represented. This time we're going to go the opposite way. So we're going to start with a word problem. I'm going to describe to you a situation, and then we're going to classify all the cash flows and then draw the cash flow diagram at the end. Okay. Okay, so for this example, let's consider the construction of a wind turbine for the purpose of generating and selling electric power. So this might be a project that Southern California Edison might undergo. Okay. All right. So this is my least favorite part of the class, but for some of you may be your favorite part. You can see me struggle to try to draw things. Don't ask me to add color, it's going to make it worse. Okay. That's my wind turbine, right? Did you know my wife actually like she follows my YouTube channel just so that she can like skim through my lectures and find out when I draw things, just so that she can roast me about it over dinner. It's terrible. All right, so if wind coming this way, it's going to hit the wind turbine. It's going to rotate, and it's going to take that mechanical energy and convert it into electricity, right? And so at the end of this, from here, you get the electricity, right? That gets added to the grid, and then Southern California Edison sells it to you to use in your home. Okay, so let's talk money. So let's say that this wind turbine or this windmill has an initial cost of $80,000. Which is pretty cheap for a wind turbine. So maybe we'll say this is just one that someone's going to have in their backyard, right? So that's going to include all the material costs, all the part costs, as well as the installation costs. So we kind of just lump it all together in one. Okay. Okay. All right. So just like any piece of big machinery, it's going to cost money to maintain it. on a regular basis. So let's say that yearly maintenance cost for this particular turbine let's say will be $9,000. Okay. So each year, Southern California Edison or SCE is going to have pay out $9,000 to maintain it. Okay. In terms of revenue, based on weather patterns in the particular area, how much wind is going to be there, it's projected to produce about $24,000 a year in revenue. Okay. All right, and then the last statement here is that at the end of its 6-year lifespan or life cycle, it is expected that you'll be able to sell the turbine and its parts for about $10,000. Okay. I usually don't write out the entire statement like this because it takes a while. But this is our first time, so I'm gonna write out the whole thing. So something like this is pretty typical. Of course, as we go through the class, it's things are gonna get more complicated than this. But this is a good example in terms of what you can expect for a lot of the process, right? So you have a situation, it's described to you in words, and it's going to be up to you to kind of pick out the information, pick out the numbers from the problem, and generate an economic analysis from it. Okay. Okay. So for this problem here, we're gonna have 3 tasks. Okay. All right. Number one. So number one is to identify and classify all the cash flows for this project. Okay. Number two is to draw the cash flow diagram. Okay. And number three, we won't be doing very often, but some people find it useful, especially just because of spreadsheets, Google Sheets, Microsoft Excel is becoming so common nowadays. A lot of people are getting used to just putting in data and reading data from data tables or spreadsheets. Number three here would be to draw a cash flow table. Okay. Cash flow table is nothing more than just taking the information that's in the cash flow diagram and putting it in tabular format. Okay. Actually, we will be using this, but we're not going to be using it until we get to taxes, probably 5 or 6 weeks from now. Okay, so that's the problem. That's the problem statement. Are there any questions on this problem so far? Okay. All right, so let's get to it. So let's start with number one. number one, we're going to identify and classify all of the cash flows. Okay. And through classifying, we're also gonna state kind of when those costs and when those benefits are going to occur. Okay. Okay. So here's the way I do this. And so, this problem's not so bad. It's a fairly short problem here. But what eventually you're going to be, you're going to be seeing problems with a lot of text. Okay. Usually what I like to do is I usually like to go through the problem anywhere that I see a dollar sign. I like to circle that, because that usually tells you that's a cash flow that you need to pay attention to. Okay. And so for this particular problem here, we have 4 cash flows for 4 things with dollar signs. Okay. Okay, so let's go ahead and identify these. All right, so first we have the first number that I circled there, which is $80,000, right? If we go back and read the problem again, we can see that $80,000 is an initial cost. Okay. Remember, initial costs are usually one-time expenses that you pay at the very beginning of the project. Okay, so this is a one-time cost. Okay. And initial costs always occur at time 0. So we're going to have a very large down arrow on time 0 of our cash flow diagram. All right, so let's look at our next cost. So our next cash flow, kind of spoil it a little bit. Our next cash flow is the $9,000 that I highlighted. Okay. The problem states that this $9,000 is a recurring cost. Okay. And it's recurring because it's maintenance that's required on the turbine each year. All right, so a couple things from this, and so we can actually glean a lot of information from this piece right here. Okay, the first being that it's a maintenance cost. So maintenance costs are almost always going to be recurring costs, and so that's going to be a cost that occurs multiple times in your cash flow diagram. Okay, and maintenance costs usually start occurring on year 1, and they persist throughout the entire project's life cycle, unless otherwise stated. Okay. And so since there was nothing mentioned about skipping maintenance or anything like that, we're going to assume that this maintenance cost is going to occur at every time period. Okay. The other piece of information that I think is a little bit easy to lose, it is mentioned a couple other times throughout the problem, is our time period that we're going to be looking at. Okay. And so we're measuring this project on the order of years. And so that tells us that each tick mark or each entry in our cash flow diagram is going to be separated by a year. A lot of times this is a minor point in the problems, but when we start talking about interest rates and the different kinds of interest rates, sometimes it matters. And so you want to make sure that you're aware of kind of how long it's going to be in between each time period in your cash flow diagram, because sometimes that's going to change what interest rate you're going to use for a particular problem. So for this problem, it doesn't matter too much, but it's important. It's an important one to note. All right, so the next cash flow that we have in the problem is the $24,000. This right here, that it states in the problem that it is a revenue. That's the amount of money that we're expected to be able to generate each month by selling the electricity. Okay. And revenue is almost always going to be a recurring benefit. And just like the recurring costs above it, for a recurring benefit, usually these start at time 1, right? And so it's the end of the first time period. And unless otherwise specified, it's going to persist on every time period until the end of the project. Okay. All right. And the last piece of information that we got from the problem was $10,000. Okay. And so this $10,000 is the sale of the turbine at the end of the life cycle. Okay. Like I mentioned before, this type of benefit that you get, so it is a benefit. It's a one-time benefit. Maybe let's write that down too. One-time benefit. At the end, okay, and so at the very last time time period, okay. This type of benefit, I was getting the name wrong, so I kept saying salvage cost, but this value right here is called the salvage value. And so a salvage value is just any benefits that you're going to get at the end for selling your part or selling your machine, after the project is done. Okay. And so salvage values are nice just because it allows you to kind of recoup maybe some of your costs at the very end. Okay. Okay. So those are the 4 cash flows that the problem mentioned, and this is how I would classify. So the next step is we're going to take this information here and we're going to summarize it all into a cash flow diagram, just so that we can visualize all this. Any questions on how I identify these, how I classified these into different categories? Okay. All right. So now that we have that, let's go ahead and draw the cash flow diagram. Oh yeah, one other piece of information we got from the problem is that the project life cycle is 6 years. Okay. And so that tells us our cash flow diagram is going to have 6 check marks. Or 7, I should say, because we need to start at 0. Okay. 2 times 0, times 1, times 2, times 3, times 4, 5, 6, 7. Okay. Wait, 6. 7 in total, but we stop at number 6. There we go. Okay. Okay. So let's take all of the information that we gleaned and put it into the cash flow diagram. Let's start with the initial cost. And so our initial cost is $80,000, right? So initial costs are always going to occur at time 0. Let's draw a big arrow down here. Okay. So this $80,000 is our initial cost. All right, the next thing we have are the maintenance costs. So the maintenance costs are going to occur at year 1, 2, 3, 4, 5, 6. Okay. Our maintenance cost is $9,000. And so we're going to draw down arrows at each of these time periods. 9,000, 1,000, 1,000. So all of these right here represent our maintenance costs. All right, next we have our revenue. And so our revenue is a recurring benefit. So it's going to be an up arrow on each of the time periods after 0. So starting at 1, all these up arrows here. Each of these is going to be $24,000. Okay. All these. That is our revenue. Okay. You don't have to label the different cash flow types. So I'm only doing it here just as an example. But you can usually just put the arrows and the numbers. That's totally fine. All right. And so the last thing that we have here is our salvage value. So our salvage value is another $10,000. Okay. So the height of this arrow in total, right? But in that last month, you're still getting revenue. So you're still getting that $24,000 from revenue. It's just that at the end of that month or at the end of that year as well, you get the salvage value. So typically in these cases, what you're going to see is just one very big arrow at the end. And that one big arrow is going to be $34,000 in this case. So the $24,000 that we got from revenue plus the $10,000 that we got from the salvage value at the end. All right, and that's our cash flow diagram there. This is our salvage value plus revenue. Any questions on the cash flow diagram? Yeah. You could, yeah. You could definitely do that. So if you wanted to represent it like this. So have this arrow be $24,000. And this one be 10,000. That's fine too. But usually like in problems and stuff, you'll see just one big arrow at the end, and then you can kind of separate it from there. Yeah. But anything that makes sense to you. Any other questions on this cash flow diagram? Okay. All right. So very quickly, let's go ahead and draw the table. Again, we're not really going to be seeing these much until we get to taxes, just because it's a little bit easier to do taxes that way. Okay. But you can take the exact same information from the cash flow diagram and put it in tabular format. And it's pretty self-explanatory, so I'm just gonna basically draw it and then we'll kind of talk about it afterwards. All right. So the way the cash flow table works, and you can break this down in a lot of different ways as well. This is kind of the very simplest one that you can do, is just have one column for the time, one column for the costs, and one column for the benefits. Okay. Each row of the table is going to represent a different time period. And so just like the cash flow diagram, we're going to start at time 0. And then each row after that is going to be a different time period. And so for this project, we're going to have 6 rows. Okay. And then each row of the of the table, you're going to represent the total amount of cost and the total amount of benefits in each time period. Okay. All right, so for time 0, the only thing we had was our initial cost. And so our initial cost, remember, was $80,000. Okay. Typically, what you do is that any cost you represent with a negative number, because that's money that you're paying out. Okay. And at time 0, you haven't earned any money yet. And so for the benefits column, we're going to leave it blank for that row. Okay. Okay. From here, we're going to list out all the costs and benefits for all the future years. And so for years 1 through 5, these are all going to be the same. And so we pay out $9,000 in maintenance costs. Meanwhile, in terms of benefits, we earn $24,000 in revenue each year. If it's a cost, is it already negative? It depends on how you want to display it. And so if it makes more sense to you to have a column called cost and have these be positive, that's fine too. This is just kind of a format for you to put in. Yeah. For me personally, I like to have a cost with the negative number so that it's a little bit easier to kind of visualize. Because I mean, for something like this, it's pretty easy because there's only one column for cost and one for benefits. But you'll see later on, once we get into taxes, we're going to have 11 or 12 different columns, and so some of them will be benefits like tax credits, some of them will be costs like state tax, federal tax. So it kind of helps when you're just kind of looking at it at a glance, which are going to be costs and which are benefits. But whatever kind of makes the most sense to you. Mhm. Okay. And then in that final year, year 6, we again had $9,000 of costs. We had to pay maintenance in that last year. But our benefits were the $24,000 that we got from revenue and the additional $10,000 we got from the salvage value. So our total benefits for that last year are $34,000. But again, if you wanted to separate this, and so instead of just one benefits column, let's say that you have a column for revenue and another column for salvage, right? You could have done that too and kind of separate them if you want, but this is just to kind of show you that you can put the same information into a tabular format. Okay. All right, and so that's the basics of costs and benefits and cash flow diagrams. So we're going to be seeing a bunch of these, over the first few weeks. Any questions on this? Okay. All right. So for the last 15 minutes today, we're going to go over the concept of the time value of money. All right. So remember, I mentioned earlier today that in general, for a commercial engineering project, so something like this wind turbine, it's desirable to have the benefits be greater than the costs, right? And so let's look at this cash flow table that I've drawn here, right? The tempting thing, to say that, if we wanted to say that, we want the benefits to be higher than the costs, is to just simply add up all the numbers in each of these columns, right? And so if we add up the numbers in this final column here, we can get the total amount of benefits. Which I don't even have tabulated, so let me just pull up my calculator really quick. 24,000 times 6 plus 10,000. Right, so the total benefits, if you just add up everything in that last column, is going to be 154,000. Okay. And the total costs, right? We can obtain the total cost by adding up the entire first column there, right? And so that entire first column is going to be 80 or minus 80,000 minus $9,000 times 6. Okay. And so our total cost in this case is 134,000. And so if you subtract these two, right, you take your total benefits, you subtract your total costs, what you get is a net positive $20,000, right? Okay. So that seems good, right? And so you look at this and say, if I build this wind turbine in 6 years' time, I'll have earned $20,000. Okay. Unfortunately, it's not that simple, right? And so this, even though I just spent the last 2 minutes doing it, is not the correct way to go about doing this analysis, right? Okay. And why is that, right? And so you would think that, when we say total benefits have to be greater than total costs, right? You add up all the benefits and add up all the costs, how else can we do this analysis, right? Well, it's not in the sense of the idea is correct, but because this project takes place over 6 years, right? 6 years is a very long time, right? The value of money is going to be changing throughout those 6 years. And so the concept of the time value of money is that money has a particular value, not only in its numerical amount, but also in the time period or the moment that you're going to be spending that money. Okay. And this is particularly relevant for engineering projects because engineering projects take place over a long period of time. And so understanding how the value of money is going to change over time, and factoring things like interest rates and inflation is going to be something that's really important for this. Okay. Okay, so to kind of illustrate this, I have a very simple example. Not really an example, it's really just kind of a thought experiment. So let's say that I have $100 in my pocket. I don't actually have $100, so don't mug me after class today. And so let's say that I really like you. I said, I'm going to give you this $100. So you're going to be given $100, but you have two options. Okay. You can either take that $100 right now, right in this moment, Or the other option is, I'll hold on to the $100 and I promise I will give it to you in a year. Between these two options, which is the more desirable option? Which is the one that's going to yield you the most value from that $100 right now? Exactly, right? Because that $100, it's cash. It's a flat amount of money, right? And so if you take that $100 right now, first of all, if you wanted to spend it, you'll be able to spend $100 worth of goods right now. Okay. And who's to say how much those goods are going to cost in a year from now, right? But more importantly, and kind of more relevant to what we're going to be talking about, is that you can take this $100 and you can invest it at a certain interest rate. And when you invest money, if you do it kind of intelligently or safely, generally your money is going to grow. Okay. And so if you wait a year, and take that $100, you're going to lose on that opportunity. Okay. And so, generally speaking, if you have the option of getting money now versus later, as long as you're not borrowing the money, so this is money that kind of rightfully belongs to you. It's always better to have it now. And a lot of engineering companies, or all engineering companies, operate under this kind of very simple idea. Okay? All right. And so the key to this thing here is interest rates. And so interest rates basically represent the rate at which your money is going to grow. Okay. So let's talk about interest. So interest basically represents the amount of growth that a particular amount of money will have once it's invested. Oops. Usually interest is represented as a percentage. So it's usually represented as a percentage of the initial amount, and that's what you see as your interest rate. Okay. Okay. So engineering companies are continuously investing in things, right? And a lot of times when an engineering company undertakes a project, they use the interest rate as a way to kind of represent how profitable or how successful a project is going to be. Okay. All right. So let's do a very quick example. I know we have about 5 minutes left. That kind of illustrates this. Okay. So let's say that your friend asks to borrow $5,000 from you to start their business. He says that it'll take about 5 years for his business to really take off. And so he said he'll pay you back with one lump sum at the end of 5 years, at an interest rate of 8% per year. Okay. All right. And so this question is very simple. So given this information, how much money are you going to get at the end of the 5 years? How much of that is going to be your original principal, and how much interest are you going to obtain? Okay. All right, so just like we did with the turbine problem, we're going to identify all the numbers here. Okay. So we only have one cash flow, so we just have our initial investment of $5,000. Okay. We have the time period. We know this is gonna take 5 years to do. And we have our interest rate here, which is 8% per year. And we've also note that it's a simple interest rate. And so we'll define that maybe on Tuesday. All right, so we're $5,000. This is our initial investment. Okay. So that's a cost, right? So from our perspective, that's $5,000 that we're losing, we're giving to our friend, and really trusting them, because 5 years is a long time to give $5,000 for, and then with the hope that he's going to pay us back. Okay. Okay. So what your friend said is that he's going to give you 8% per year, and so that means that each year. Each year, your investment of $5,000 is going to grow by 8% of its original amount. Okay? And so if we were to compute this, we take our $5,000, we multiply it by 0.08. That's going to give us 8%. Okay. So 0.08 times 5,000 is $400. Okay. So each year we're going to accumulate $400 in interest. So of course, we're going to do this for 5 years. Right? We're going to take that $400 and multiply it by 5. And so the total amount of interest that we're going to obtain from our investment is $2,000. If we add this to the original $5,000 that we lent our friend, because he said he's going to pay us back, the total amount of money that we're going to get at the end of that 5 years is $7,000. And so through our friend, which we're using as an investment here, our $5,000 grew by 2,000, right? So our 5,000 turned into 7,000. And so this is an example of how kind of money's value can change with time. Okay, if you invest it smartly and you have a friend that you really, really, really trust for some reason, $5,000. Okay. All right. Any questions on this example here? Okay, so this example, we use simple interest, and so that's usually not how the world works. So the world uses something called compound interest, but we'll talk about that on Tuesday. Okay. All right. So thank you guys for coming today. Hope you guys enjoy the rest of your day. Hope you guys enjoy your weekend, and I will see you guys back here on Tuesday. No, you can attend on Zoom as well. The only class sessions where I require you in person are going to be the exams. Yeah, but you're free to attend on Zoom for the entire semester, except for the exams and except for the presentation as well. The presentation I'm going to require you to be in class.
Oh, you got the last one. Or.
So it's actually president mandatory because on Tuesday,
Oh, you have.
I only have this class, so.
Yeah.
Oh, it's not. So I don't check attendance. So I post all the lectures afterwards. Yeah, I do ask that you watch all the lectures.
Yeah. I was saying like I can watch it on Zoom like when the class.
Yeah, that's fine.
All right,
Yeah.
perfect.
Yeah.
I think I'm gonna move the phone. Really? Yeah, because I have lab students, I don't have to pay involved. I know that some of them have. Yeah, exactly. Oh, no, I think a lot of them, yeah. I was second. Wait, you have a share.
Someone this morning when I tried.
Someone got in, so you might be second now. Is now first. Yesterday I was second.
Yeah.
Oh, I don't know. When I checked this morning, I was like, number 3. But I haven't looked at it since.
Well, someone dropped the class, someone came in. Almost there.
Frankly. Last time I had 15 minutes.
Oh, Professor.
See you next week.
Yep, have a good one.
You too.